Good morning, good afternoon, good evening. Welcome to our class again. The last time we treated Newton's first law of motion, but today we'll be looking at the Newton's second law of motion. Okay, Newton's second law of motion has to do with force, alright? That the law states that the rate of change of linear momentum is directly proportional to the applied force. Or you can say that the applied force on an object is directly proportional to the rate of change of linear momentum. Alright? What do we mean? That the velocity changes from initial velocity to final velocity. Alright? So we're going to be having that the force is directly proportional, alright? Force is directly proportional to rate of change. And the force directly proportional to rate of change of linear momentum. Therefore, we're going to say force equal to rate of change of linear momentum. Momentum is mass times volume, alright? So it's with time. Okay? Now, therefore, we're going to have the F, which is force. Rate of change of linear momentum is mv minus mu. Alright? Over what? The time. We are still having our direct proportional here, okay? Now, since we have mv here, we can directly say that force is directly proportional to m bracket v minus u over what? T. At this point, of course, you know this. When initial velocity is equal to 0, when u is equal to 0, initial velocity, we're going to have force is proportional to mass v over what? T. Okay, from Newton's equations of motion, we can say that A is equal to what? V over what? T. Hence, force is that proportional to m what? A. Introducing a constant, we can introduce a constant. You can introduce a constant, okay, which is k. Now say F is equal to k m a. K is equal to 1, a constant. Of course, no, it's a constant. So F is equal to m what? A. This is the relation for Newton's second law of motion, that the force on an object, the net force, is directly proportional. So you can say that the net force acting on an object is directly proportional to the linear momentum, okay, and inverse proportional to the what? The mass. All right. So yeah, we're going to consider the force, the mass, and the what? The acceleration. Right. So this is how to deduce Newton's second law of motion. Thank you for watching. See you in our next class. Don't forget to share, like, and comment.